In yesterday class, we were discussing about this that there exists a polynomial of degree n if we have n plus 1 data points, and that polynomial is unique. Then, like this is already like we have discussed this proof earlier classes. Now we have another theorem like if we have like n plus 1 data points in the interval AB, then if px is the like approximating polynomial of degree n and fx is the actual function. So here fx is the actual function and px is the approximating polynomial that best fits these n plus 1 data points. So the difference is the actually error. The error in the interpolating polynomial. So the error in the interpolating polynomial is actually the original function minus the polynomial function, and it is actually equal to this one. So we have to prove that the error in the interpolating polynomial is equal to this, and where this xi x, this xi x lies in the interval AB. And here A is like your x naught and B is your xn. So to prove this result, let x be any point other than xi. So what we are doing here, we are actually right now we are making fix that x is not the one of the xi. Here like we have n plus 1 xi's like x naught, x1, x2, xn. So x is other than that. And then we define a polynomial like this. Wt equals to, it's a polynomial in T, and this is a product notation like
so if you see these things, if you quantum notation, then what we have already known is starting from time independent solution. Time independent solution. Because this starting process is everything is doing starting from time independent. So we know that the xi is equal to Lisa. So if h is the Hamiltonian, so minus x.
okay. So here this symbol actually representing the product. I think all of you know this. Actually, this means that we are writing t minus x naught and t minus x1 product with t minus xn. So this symbol, this is known as the product symbol. And like in summation we have plus between the terms. When we have summation symbol, this in product symbol we have product between the terms. Like first term when I equal to 0, it is t minus x naught, then t minus x naught, x1 is the second term, and then t minus xn is the last term, and we will product all these terms. So this is the way we have defined a polynomial Wt, and it is a polynomial of degree n plus 1, because it is starting from like from xn to xn, n t's are here and 1 t is here, so it is a polynomial of degree n plus 1. Now we define another polynomial phi t, and phi t is the polynomial such that it is ft minus this pt, that is a approximating polynomial, and then lambda into, actually this one is this one is lambda into is omega t, this omega t. So where lambda is a constant, and we have to determine for fixed x such that phi x equals to 0. So for this particular x, we calculate lambda by assuming this condition phi x equals to 0. So if I put phi x equals to 0, so from equation 2, what we will get phi x equals to fx minus px minus lambda wx. Since we are taking phi x equals to 0, so we will get 0 equals to fx minus px minus lambda x, and finally lambda equals to this one. So if I put this lambda here, if I put this lambda here, then I have actually defined this polynomial phi t like this, ft minus pt minus fx minus px divided by wx into wt. So now I have a polynomial phi t, and it is a polynomial such that it is a 0 at x. If I substitute x equal to t here, sorry, t equal to x here, so you can see that wx will cancel out wx, and then fx will cancel out this fx, and pt will cancel out this, px will cancel out this px, because when you calculate x, then you have to phi x, you have to substitute t equal to x. So phi x is 0. So this polynomial phi t has at least one zero, one is that x. Now since px, fx, wt and wx are functions in Cn plus 1b, so what is this Cn plus 1b? Like here in the statement of theorem, we also have this one, like the f is a function belongs to the set Cn plus 1 ab. So it is like it is a this set is a collection of function which are n plus 1 times continuous. So like continuously differentiable means like f is differentiable, f dash is differentiable, f dash is also, f triple dash is also continuous function like this, and like fn is also continuous function. So it's representing a set of continuously differentiable functions of over this interval AB. So since this is actually px, we have already assumed it is belonging to this set. Now this fx is the assumption of the theorem that f is belonging to this. But what about px? Why we are saying px is also belonging to this? Because px is a polynomial, and you know that polynomials are continuously differentiable. You can differentiate them. So this pt being a polynomial, it is also continuously differentiable up to n times. Similarly, this wx also, if I write here wx, it's again a polynomial. You can see because these xi's are constants. So if you write x here, so this product will give you a polynomial of degree n plus 1. So this is also continuously differentiable, being a polynomial. And similarly, wt also. So it means all of them belongs to this set. It means all of them are continuously differentiable. So if all of them are continuously differentiable, and phi t is this one. So phi t is actually combination of all these. Ft, Pt, Wt. So it means phi t is also belonging to this set. So phi t is also the continuously differentiable function. Now we count the zero of this phi. Like what are the total number of zero of this function phi? So 1 zeros we have already with us, because here we are taking x as a fixed point and t as a variable we are taking here. So we have taken one x in the interval first in AB, and then we fixed it, and for that x we are doing calculations. So one phi x is 0 because the construction of phi we have created like this. Then another thing we will check, when I substitute t equal to x naught. So if I substitute t equal to x naught here, if I substitute,
suppose two waves are propagated, then this kind of
if I substitute t equals to x naught here, what will happen? It is f of x naught and it is p of x naught. So f of x naught and px naught are equal because this is the interpolating condition. Whatever our approximating polynomial, when it comes to the nodes like x naught, x1, x2, this p of xi should be equal to f of xi. So in particular for x naught also. So f of x naught equal to p of x naught. So this term is 0. Now we go to this wt term. In wt we have a factor like x minus t minus x naught here in the product. So if I substitute t equal to x naught, then this, due to this factor x naught minus x naught, if the whole product is 0, so the wt is also 0. So in we will see that in general, in like for x1, xn, all those data points set, this phi t is 0. So now we count the 0, like 1 0 is this one, second 0 is x1, and third is 0, and n plus 1 is 0 is xn. So this is like having n plus 1 zeros from here. If I count n plus 1 0 from here and 1 0 from here, x is also a 0 to this polynomial phi t. If I substitute t equal to x, I will again get the 0. So it means this polynomial phi has n plus 2 zeros. N plus 1 these data points, and 1 we have chosen, we have created phi x like such that phi x equals to 0. So now phi has n plus 2 0, and the name of the zeros are like x naught, x1 up to xn and x. So by the Rolle's theorem, if you remember the Rolle's theorem from your first semester, phi dash has at least n plus 1 0 in the interval. So why we are saying that? Suppose like I take x naught on a line I am taking, and suppose this is x naught and this is x1, and somewhere we have x2, somewhere we have xn. Suppose I say xn minus 1 instead of this, I will say. Suppose I am here assuming xi, and here I am assuming x, and then xi plus 1, and then xi plus 2, and then it goes like x n. So suppose these are the n plus 2 points lies on the line, somewhere they will lie. So here I have information phi of x1 is 0 and phi of x naught is also 0. So if there is two zeros, and it means phi of x naught equals to phi of x1, it means there exists a point here such that phi dash of x is 0. There exists some point, you can say C1 exists. Similarly, there exists one point by Rolle's theorem such that instead of this, like like phi of C1 0. Similarly, phi, this is coming from this Rolle's theorem. So like here we are having like n plus 2 points. So and each between every pair of points we have 1 0 of the function phi dash. So it means we are having n plus 1 0 of this phi dash function, because phi c1 is 0. Similarly, phi c2, phi c3 we will get, and all of them, all phi dash function is 0 at all these n plus 1 points. So we have so here phi dash has at least n plus 1 zeros in the interval. And since phi is belonging to this Cn plus 1 AB, so phi dash is also differentiable. And again, this phi dash is having n plus 1 0. So it means again we are having n plus 1 points of phi dash, and in between we will get like some b1, b2 points, such that at those points the derivative of phi dash is also 0. So phi double dash is having n0 again by the Rolle's theorem in the interval AB. And we will go in this way.
At least you understand the scattering.
So we will find that phi n plus 1 has at least 1 0 in AB. Because likewise 1 1 0 is going to reduce. So if phi dash having n plus 1 0, phi double dash has having n 0. So phi n plus 1 x has at least 1 0 if we repeatedly apply Rolle's theorem on the function phi, and then phi dash x, then phi double dash x, and then phi n plus 1x. So there exists 1 0 of the phi n plus 1x function. Now we say that that 0 is xi x. So we assume that whatever 0 of phi n plus 1 exists, we gave it name to xi x, and it is 0, and it lies between the interval a b. Because there exists 1 0, and we are naming that 0 to xi x. So this information we have. Now what we actually got here, that we find a point xi x such that phi of phi n plus 1th derivative at xi x is 0. So our next job is to differentiate this phi function
is very high because both are similar.
n plus 1 times,
Almost similar.
and we'll see what is the value is coming like.
So always there is two things happening. Momentum
This
is 100%.
is equal to this. So if I differentiate this n times, n plus 1 times with respect to t, what will I get? We'll see.
That is happening. So what?
So like we are differentiating our phi t function n plus 1 times with respect to t. So since we don't know the form of the function ft or fx is, we don't know what kind of this function. So maybe its n plus 1 derivative exists. But what about this? It is p n plus 1 t. We are differentiating the polynomial pt
Plus b star
n plus 1 times.
a plus b plus c.
Okay. So what is the degree of this
there is three different processes there.
pt polynomial?
Know that in elastic scattering there is no change of energy. Momentum is always conserved, but energy cannot conserve. Energy may be dissipated.
So degree of this polynomial is
Absorption
n plus 1. So if we differentiate, not pt, sorry, actually pt we are talking about.
Then
So if you remember the what to say, the last theorem, or in general we have generally talked about this, like if we are having n plus 1 data points, we can fit a polynomial of degree less than equal to n, like at most degree n. Px cannot have more than n degree. So it means this pt, if px is not having more than n degree, so pt is also a n degree polynomial in t variable in place of x. And if you differentiate a n degree polynomial n plus 1 times, if you differentiate n degree polynomial n plus 1 time, you know that it should be 0, because n times it is constant and n plus 1 time it is 0. So here pt, that is approximating polynomial, is of degree at most n, and you are differentiating this n plus 1 times. So this should be 0 if I differentiate the polynomial p n plus 1 times. So that's why we are writing here 0. Because pt is an approximating polynomial, and being an approximating polynomial, its degree is at most n. So and we are differentiating it one more time, like n plus 1 times. So it is 0. Now we come to this wt. Now we have to differentiate wt polynomial also n plus 1 times. Now here you can see this is a n plus 1 degree polynomial, wt. It's a polynomial in t, and since the product starts from t minus x naught, t minus x1, and t minus xn. So if I product is this all this, I will get one term as t raised to power n plus 1, and rest of the terms I also will get like t raised to power n some constant, t raised to power n minus 1 some constant. But the term having t raised to power n plus 1 is having 1 as a factor, because you can see that here is 1, here is also 1, here is also 1. So if I multiply t terms only, this I will get t raised to power n plus 1. So it's a n plus 1 degree polynomial with the coefficient of t raised to power n plus 1 is 1. And now I differentiate this n plus 1 degree polynomial n plus 1 times. So if you differentiate n plus 1 degree polynomial n plus 1 times, so you know that like whatever the term having degree less than n plus 1, they are 0. So and for this we know that it is like n plus 1, then n minus 1, then it goes to like 2, 3, 2, 1, like n plus 1 factorial into the coefficient of t raised to power n plus 1. So that's why we have written the n plus 1 time differentiation. It's like it's actually we are differentiating here, not like here we are differentiating. So we are differentiating n plus 1 time this wt polynomial, and we are getting n plus 1 factorial into 1 as a coefficient of t raised to power n plus 1 in wt polynomial. So we are having with us this one, and from here we can write what is the value of the lambda. Lambda we have already calculated. Lambda is this one, fx minus px upon wx here. So we'll substitute this value of lambda also here, and then finally we have this one. Now we have obtained the form of the phi n plus 1 t function, because this phi of n plus t is again a function in t, and this is given by this equation. Now in this we have one information that this phi n plus 1 t having 0 at the point xi x, and where xi x is lies in the interval ab. So if I substitute t equals to xi x in this equation, what will happen? Phi of xi x equals to f of n plus 1 time derivative of xi x minus fx minus px upon wx n plus 1 factorial, because there is no t. And this one is 0 because we know that xi x is a 0 of phi of n plus 1. And then we can simplify it like that. We take this part to the other side, we will have this one, and like then this one, if we simplify, like if we divide this n factor n plus 1 factorial, then we keep it here and multiply by wx there, and then we substitute the value of wx, like we know the wt, but if I replace here t by x, I will get the wx also in this definition of wt. So if I write t equal to x, I will get the this one. Question will come. What is the equation of scattered?
4 5 4 jega
And then and what we have find the difference between the approximating polynomial and actual function, and which is equals to this. So the error is given by this. So this completes the proof. So the error in an interpolating polynomial, if we having n plus 1 data, is given by this.
Question can be arise. Okay.
So for today I stop here. I will find some new theorems for the next class. And today I give attendance to all of you. So and now Abhijit, like we have to decide like test date, class test 2 date.
Yes, sir. Next week you can arrange next week, sir.
Next week is Diwali. Is everybody happy with this?
Oh,
And some there is a Ningol Chokoba also.
oh,
Some local people. So like I think you are busy till 10. Most of the people.
sir, I think the syllabus is complete by this week.
Syllabus, yes, yes. No, I will continue. It is not like complete.
Yes.
It's like
Sir,
I
after,
will now. I will take theoretical results, na?
yes, sir.
So
Sir,
that
then
you have
after
like
the
enough time in exam.
yes, then after Diwali, sir, but I think 1 week will be there also. Sir.
Do
That
you
is,
know the end term date?
yes, sir, sir. 22 November to 5 December.
So I think it is better to have in the next week, like on November, November 2, because like you maybe forget if I take later, no?
Okay, sir. As you wish.
Like it is better to all of you have this class test 2 on 2nd of November, because now you have little bit something in your mind like 5-day holiday, and it may be a problem. So shall I fix the class test on 2nd of November, all of you? I think no one is saying no, so everybody, it is assumed to be yes. Okay. So we will meet again tomorrow, and on 2nd of November we have class test 2. I
Okay.
will text this in the WhatsApp group also. Okay, then now I am leaving. You may also.